Hi everyone. So this video is going to give you an example of graphing a rational function by hand. Okay, so you want to do this one. I know you can obviously punch it in and graph it on the calculator, but you want to be able to do these basic ones by hand by following these steps. So I have an example here. F of x equals 2x squared minus 5 over x squared minus 4. So the first thing I'm going to do before I even start getting into these steps is I am going to, if I'm able to, I'm going to factor this. Okay, the top has no GCF and it can't factor any further, so I'm going to leave that alone. But I am going to factor the bottom into x plus 2, x minus 2. And I always want to do that first so that if there's anything that, any common factors that can cross out, I do that, because that's going to affect my asymptotes. If I don't have it in simplest form, I may get more asymptotes than I should. Okay, so step one is to identify the vertical asymptotes. We're going to be able to tell a lot about this graph just by looking at the asymptotes and seeing what we have there. So the vertical ones are always determined by what makes this rational function undefined. So I talked about in earlier slides that when a fraction is always undefined when the denominator equals 0. So my denominator in this case is the x plus 2, x minus 2. So a lot of times people say, what are you, just getting rid of the numerator? And it's not that I'm getting rid of it, it's just that to find the vertical asymptotes, I'm only concentrating on when is the denominator 0. That's what's going to make this undefined. So that's going to happen if x is negative 2 or if x is 2. So those two things can't happen. These two things I would have to exclude from the domain. Okay, x is not allowed to be either one of these because then I get a 0 in the denominator. So far what I have are vertical asymptotes, and I usually just abbreviate these, at the vertical line x equals negative 2 and at x equals 2. So right there I have two vertical asymptotes, which usually means this graph is going to be in three pieces, okay, because the vertical asymptotes, if you think about them, they break that graph into three pieces. All right, so now we're going to decide if the function has horizontal asymptotes by looking at the degrees of the numerator and the denominator together. Okay, so we have three little rules here. We break this up into three scenarios. Okay, the first one would be if the degree of the numerator, that's supposed to be an of, is greater than the degree of the denominator. Okay, we'll talk about that in 1 second. Case 2 would be if the degree of the numerator equals the degree of the denominator. And then scenario 3 would be, let's see, if the degree of the, which one haven't I done? Let's see, numerator is less than that of the denominator. Okay, so if the degree, I'm going back to case 1, if the degree of the numerator is greater than the denominator, meaning in this case our degrees are going to be equal, so we're going to be case 2 because they're both second degrees. But if the degree of the numerator is greater than that denominator, then there are no horizontal asymptotes. Okay. If they're equal degree, then there's a horizontal asymptote at the line y equals, and then the equation of the line would be the ratio, I'll show you this with this one in a second, of the degrees, or of the numerator and denominator. It's easier for me to just show you on that example. Okay. And then the last case scenario would be if the numerator of the degree of the numerator is less than that. So that means the top degree is a smaller degree than the denominator, and then you would have a horizontal asymptote at y equals 0. Okay, so our case, back up at the top here, ours, they're both second degree. Okay, so when I look at the coefficients, okay, so maybe let me just kind of clarify here. It's the ratio of, and let me insert in here, coefficients of each one of those. So the coefficients of the highest power in the top and the numerator and the denominator, my coefficients would be this 2 over 1. Okay, so in this case, this one right here has a horizontal asymptote at y equals 2. Okay, so it's that ratio. And that's if my degrees on the top and the bottom are both equal. So right now I know 3 things about this graph. Okay, so what we need to do is be able to fill in now in between these asymptotes and see what's happening. And that's when we turn to the intercepts. That's always the next logical thing to find. Okay, so now we'll find the y-intercept. That's always the easiest one. Let me just write our function up here before we forget. So it was f of x equals 2x squared minus 5 over, I can put it in either form. It doesn't matter if you have it in factored form or not right there. So find the y-intercept. So that means I'm going to find, really, when I'm plugging in a 0 for x. Okay, so 2, 0 squared minus 5, 0 squared minus 4. Okay, so this does drop out, and that drops out, but I get a positive 5/4 from that. So my y-intercept is the ordered pair, 0, 5/4. Okay, so there's 1 point on my graph. And my next one, I'm going to find my x-intercept. So this I am plugging in a 0 for y. Okay, so for f of x. So it looks like this. Okay, so what I end up doing here, okay, whenever 0 equals that fraction, the denominator goes away. And the reason it goes away is because if I multiply both sides, if I'm trying to get x squared alone to see what x has to be, I'm going to multiply both sides by this. Okay, I don't show the work for this every time because the same thing happens over and over, is that those go away and 0 times anything is 0. So I still end up with 0 equals. So you notice that when I have a fraction equal 0, really means the numerator has to be 0. The denominator can be any number. For the fraction to come out to be 0, the top has to be a 0. So if I solve this, let me come up here. If I bring over the 5, divide by my 2. Oops. So I have x equals plus or minus square root of 5 halves when I take the square root of both sides. So that, let me move this up a little bit. That means if you make that into a decimal, it's about 1.58 plus or minus. And so my x-intercepts, I have 2 of them here, are at negative 1.580 and then again at 1.580. All right, so let's see what we've got on a graph here. Oh, I think I have one more thing I'm going to check. Okay, so find at least 1 point in between each of the asymptotes. I think we're going to do that on the next slide to show you. I'm going to show you this on the graph. It's easier, I think, once we picture those asymptotes, what points it makes sense. And determine whether it has any symmetry. So this is really checking, if we want to see if there's any symmetry, we're really checking if my function is odd or even. Okay, and if this one, if we check it, this function right here would be even. Okay, because if I plugged in negative x, I get the same thing as the original function. Okay, so this would mean that this has symmetry. This is symmetric over the y-axis. Okay, so that gives us some ideas of some points as well. So let's put everything we have on the graph and see where we're at and see what we need more points for. All right, so I'm going to draw in all my asymptotes in dotted lines. So we had a vertical asymptote at x equals 2. So my graph has to approach that, and x equals negative 2. So my graph has to approach those 2 lines. And I had a horizontal one at y equals 2. So it has to, see, this is how you can tell my graph is in 3 pieces, because of the way it's really the vertical asymptotes that breaks that graph into 3 sections. If you only have one vertical asymptote, then you have two parts to your graph. All right, so let's fill in some points now. We had, okay, our y-intercept was 5/4, so that's 1 1/4. So just right about there. My graph might not be perfect, so I can't make really small dots. And I had x-intercepts at 1.58 and negative 1.58. Okay, so this so far means this part of my graph looks like this. Okay, it's going to go down and approach, go down and approach. Okay, so I'm not positive where the other parts of my graph are. I can take a guess, but I really need some more points. So let me just write our function up here. Oops, that's not supposed to be a negative. I was trying to write my equal sign there. It was 2x squared minus 5 over x squared minus 4. So what I'm just going to do is I need to see what's happening to the right of the x equals 2 vertical asymptote and to the left of x equals negative 2. So I'm just going to find f of, let's see what happens if I plugged in a 5. You know what? I'm not going to choose that value only because I think it may start to get too big. Well, maybe not. Let's keep with it. It doesn't really matter what I choose. I just need to get an idea of what section the graph is in. So if I plug in x equals 5, I have 2 times 25 minus 5 over 25 minus 4. Don't worry if it comes out to be a fraction. So on top we have 50, so we have a 45 over a, what do we have there, 21. Okay, so the idea, so this would be a little over 2. Okay, so this would be 2 and 3 over 21. Okay, if I just, so that's really 2 and 1/7. So the idea is if x were 5, this comes out to be a little over 2. Okay, so it means it puts my graph right there. My point right somewhere about there. So that's all I really needed. And I do know that this is symmetric over the y-axis. So if I plugged in a negative 5, it would be a mirror image of that. And that's actually enough for me to know that if it's got to approach these asymptotes, it's got to look like this. That's all I really needed. It doesn't have to be a perfect point. We just have to know what section of the graph it's in, and look at that. Now I've got a pretty good graph. Now the more points we got, if we wanted to get more out, you know, by 10 or negative 10, or even closer to the x equals 2 and negative 2 vertical asymptote. But this is a really detailed, we've got intercepts, we've got other points, we've got all of our asymptotes. So that's a great graph. So you can check it using your graphing calculator. So that gives you some general steps to approach kind of any rational function that you have to graph.